So last time we talked about chapter 15 and how sample mean, what is the distribution of sample mean. Okay, so here we have each single observation has a normal distribution of mu and sigma. Mu is mean, sigma is a standard deviation, and this is a population distribution. And then when we wanted to solve a question related to population distribution, we started with x, we found z, a standardized value for x, and then we found the probability of z greater than something or smaller than something or between something, right? Then in chapter 15 we talked about sample mean xbar. So we call this sample mean. And according to central limit theorem, if we choose a large sample size, this xbar, sample mean, will have a normal distribution with the same mean as mean of population, but the standard deviation will change to sigma over square root of n, and this n is the sample size. So this xbar was sample means or average of n observations. And this n observation goes here and reduce the variance to sigma over square root of n. We call this sampling distribution. And if you want to be more kind of precise, you will say sampling distribution of x bar, which is sample mean, right? So x bar itself is sample mean. So this is a sampling distribution of x bar or sampling distribution of sample mean, right? So we have all this information. So now, when we had population distribution, we started with one single observation, and z for this one single observation was subtracting mean of population from one single x and divided by a standard deviation of population. So if we want to follow the same thing, so here we start with x bar, and then z for x bar will be x bar now minus the mean of x bar, which is this one, right? Divide by what? A standard deviation of x bar, which is sigma over a square root of n. So now if we want to find any probability for x bar, we should change it to z, and z for x bar is now different. It's not that much of a difference. The only difference is like you are dividing by standard deviation of x bar here, and here you are dividing by a standard deviation of x. So we have all these formulas here, and the rest, finding probability of z, is exact same as before. We can, after we find a z, we can probability of z less than something, greater than something, or between something. So everything else is the same. The only step is z that is changing. Okay, so now we have all this information. It says a bottling company uses a machine to fill the bottles with olive oil. The bottles are designed to contain 475 milliliter. In fact, the content vary according to a normal distribution with a mean of. Okay, so as soon as I hear this, I will write down the distribution of population, which is normal, with this mean and this standard deviation. Okay? And then they are saying, what is the probability that a single randomly selected bottle? So we are looking at this one, right? One single observation contains less than 470. So we start with x equals 470. We find the z value for this x using the formula. Here we have z is equal to 470 minus 470. 3 divided by 3, we will have -1. Correct? So the z value is -1, but we know that maybe it's difficult for you to, find just -1. So we make it the way we used to see a z value with 3 digits. Okay? So we have the z value for this x. If you want to show this on standardized normal distribution, we have this line. Then we go back to the question. It says the probability of a single randomly selected bottle contains less than this much. So this z was for x equals 470, correct? Less than means all the area on the left side of this -1, correct? So we should find this area, and this area gives us the probability of a single randomly selected bottle contains less than 470 milliliter of this olive oil. Okay, so how we find this? From table A, page 1, because our z is a negative value, right? So -1.00. So we have this number, 0.1587. This is the probability, correct? If we want to convert this to percentage, we can say this probability says this much percent of time a single randomly selected bottle contains less than 470 milliliter. So 15.87% of the time a single randomly selected bottle contains less than 470 milliliter of this. Do you have any question? So this was all from chapter 3, nothing extra. So now, to solve part B. Part B says, what is the distribution, mean, and the standard error of sample mean of 6 randomly selected bottles? So the number of the sample size is 6, correct? Distribution, mean, and standard error of the sample mean. xbar is sample mean, correct? So the distribution of xbar is normal. Normal. So this is the distribution of sample mean, correct? Mean of sample mean will not change, and it is exact same as the mean of population, 473, correct? So the mean of sample mean is 473. A standard deviation of sample mean changes to sigma over square root of n. So instead of sigma we have 3, because we know here this one was sigma, This one was mu, right? So we have 3 here. And then instead of n, we should write down 6. So this is the standard deviation of sample mean. We call this a standard error. So standard error is sigma over square root of n, and a standard error is the standard deviation of sample mean. So the distribution of sample mean is normal with this mean, with this standard deviation, correct? Mean of sample mean is 473. A standard error of sample mean is 3 over square root of 6. So you can calculate this to see what is the standard error exactly. What is that? 3 over square root of 6 is? 2. Okay. Correct? So now, for the next part of this question, do you have any question so far? Okay. Part C says, what is the probability that the mean of 6 bottles is less than 470? To solve this problem, this one, we should use this information we have. First, we should know what is the distribution of xbar, because xbar is mean of 6 bottles, correct? And we already found this in previous step. So we need this, first of all. Second, we need this z. We should know how the z value will change if we are going to talk about xbar. Okay, so I'm going to use this information to answer part C. Part C says, if we start with x bar equal 470, in part A, we started with x equal 470, correct? But here, because they are talking about average of 6 bottles, we start with x bar equal 470. For this x bar, we should find the z value, which is x bar minus mu divided by sigma over square root of n. Correct? Do you have any question? Okay. So, x bar is 470. Mean of x bar is 473. Correct? 473. A standard error of x bar, now we know that, 1.22. Or you could just write down 3 over square root of 6. So 1.22, we have negative 3 over 1.22, which is negative 2.46. Correct? Let me draw a normal distribution, a standardized normal distribution. Now negative 2.46. Let's say it's here. Okay. It says, what is the probability that the mean of 6 bottles is less than 470? Means we are going to find the area on the left side, because this area shows the less than probability, correct? If it was more than probability, we would shade this area and we should find this area, correct? So this one. 0.0069. 0.0069. Correct? So now, percentage for this will be 0.69%. Okay. So now how I can explain this? We are talking about average of 6 bottles, correct? So there is 0.69% chance that the average of 6 bottle, or you can say in average 6 bottles, in average 6 bottles contain less than 470 milliliter of this ion. Actually, yeah, the average of 6 bottle is more correct. So if you have 6 bottle on this 6 bottle, on average they contain less than 470 milliliter. Do you have any question? No? Sure? Part D says, what is the probability that the mean of 6 bottles is more than 475? So again, we are talking about sample mean xbar, correct? Still, we are going to use the same distribution, right? But now we are starting with xbar equal 475, and we find the z-value for this xbar minus mu divided by sigma over square root of n. Xbar is 475, mu is 473, standard error is 122, and now we have 2 over 1.22 positive. One point 64. So 0 is here, 1.64 is here. What they are saying? More than. So what area?
Right side.
Right side, exactly. But now, here is the part we learned in chapter 3. We cannot find the area on the right side of z-value from the table, correct? So from the table, we just can find the area to the left side of z-value, right? So we find that area to the left side of z-value. What is that point?
So when you take the z-value, it's 0.9495.
9495.
And then you have to subtract that from 1.
Exactly. So this question mark here will be 1 minus 0.9495. 0505. 5%?
Yeah, 5%.
Correct? Five, 5%. Correct? So now we're right now. There is 5.05% chance that the average of 6 bottles contain what? More than 475 milliliters. Any question? Are you sure? So it seems you studied chapter 3, you reviewed chapter 3. Okay, good. So from now on, I will do that to my other semester, other classes. I never did that to put a kind of pop quiz for chapter 3 and force them to review that. From now on, I will do that. That was a good choice. So, can you solve the next question now?
Yes.
Do you think you can solve on your own? Okay. So I will give you time. Solve this one. Or let me see how much time we have. We have 45 minutes. So let me give you another question also. So we can solve more. I had okay. We will solve pizza question. Okay, so when you are done, please solve the pizza question. Okay? All of them. So now you know how to solve it, right?
Yeah.
Please try on your own and then I will solve it too. Thank God, class. Good. Yeah, I saw the
I'm doing it.
progress.
I'm doing it in my head.
You will get 0.
Why would I get a 0? This isn't an assignment.
Actually, you know what? I could say, okay.
Oh, I never signed it actually.
Oh. I would remove your attendance and say,
Jordan wasn't. Yeah. I signed him last week.
Oh shit.
I signed him last week.
Yeah.
okay, be fast so we don't lose time. Okay? extra time, we can solve one question.
Is there 4? Thoughts were getting 4. Yeah, okay.
So, if you remember in table, do you remember I was talking about if your z-value is so bigger than what you have here, or so smaller than what you have here? Okay, let's have a kind of review. So in first page, all the z-value, look at this. First page, all the z-values start from negative 3.40 up to negative 0.09, right? I'm talking about z-values, negative z-values. So if you don't have the z-value here, and for example, your z-value is negative 4.5. So what is the probability on the left side of z-value? So imagine negative 4 point something will be here, right? The probability on the left side will be 0, almost 0, right? So imagine you have a point on this, and then area to the left side will be so small, which is getting closer and closer to 0, correct? So if you don't have a z-value in first page, a z-value is negative, the probability on the left side is 0, correct? On second page, all the probabilities start, all the z-values start from positive 0 to 3.49, right? For example, if we have a z-value 4.8, will be right here, right? And then the area to the left side will be covering all the distribution, 100% of distribution. So area to the left side will be almost 1, correct? So after class, we can talk about this more.
So if it says exceeds, that means more than?
More than, exactly. Exceed means more than.
And if I got 4.04,
Positive.
Almost 0%. Because if 4.04 is already all the way over here, and then it says more than.
All area and then more than, you should subtract that from 1. 1 minus 1 is 0.
So
Exactly.
0.
Almost 0%.
Yeah, I do if like one hand, but it's not a steer. Steer. Just kidding. Getting in a car accident. Just kidding. Oh yeah, that's all right. Back. Like Converse from my house.
Are you done? 5 more minutes and then I will stop. No, okay. Yeah. So, yeah, I think I need 25 minutes to solve them. So you have 5 to 10 minutes more. Okay? Yes. So one thing, if you remember in chapter 3, we were able to solve probability for between two z values, correct?
Yeah, I don't remember that.
Subtract one from another one. Subtract one probability from another probability, correct?
Yes.
So if you have the same question for average of n observations, still you will do the same thing. Find the probability for less than, find the probability for more than, and subtract them. Same way. Okay?
That's the one I got wrong in the homework.
So
That's like,
you should draw a picture for that, and then you will understand. Ask me that question after class.
When's our final?
Final is on 6th, right? May? Monday.
after finals, do I show up to class?
That question always is on my nerve. Why you want to be in class after final? Really?
Should I get socks after the final?
Yeah, I actually could imagine.
Do I get extra credit? If I come after the final? I'll just come in here and just chill.
It says 2 decimal places.
Yeah, you will miss a statistic class with me, and that's fine. I will not be here. But actually, we should set up a time. So if you want to go through your final exam and see, what you did, wrong, or if you have any question, we will set up time, okay? And I will be in my office after that. Oh, actually, not exactly that day because I have exam too. Maybe 2-3 days after exam. I will set up a time.
Wait, so what's the final exam over? Like which?
All 4 chapters, the last 4 chapters are on 12, 15, 16, 17. Hmm? No, do you want that? Do you want that? Okay. So don't put that in my head. Are you done? Okay, so try to solve it. Okay. So it says, in a state fleet which operates and manages car rentals for their employees found that the tire lifetime for their vehicle has a mean of 50,000 miles and the standard deviation of 3,500. Okay, so we have X. Our population will have this mean and this is standard deviation, right?
Yeah.
Oh, so this is single observation and this is the population distribution. It says what is the probability that a single randomly selected tire has a lifetime more than 52,000? Okay, we start with X equal 52,000, correct? Z is equal to X minus mu divided by sigma equal to 52,000 minus 50,000 divided by 3,500. So what is the Z? Huh? Z, fine.
Oh, 2,000 over 3,500 equals 0.57.
0.57. Okay, and then we have 0.57 here, more than or less than? Huh? More than. So we need this area. Correct? So what is this area from table? 0.757. Then this will be 1 minus 0.715. Am I right? Okay, so what is that? 0.2843, which is 28.43%. Okay, there is 28.43% chance that the lifetime of tire what is more than 52,000 miles, right? Correct?
Yes.
Okay, this was part A, right? Now part B. It says, where is that? What would be the distribution mean and a standard deviation, a standard error, mean lifetime of random sample of 50 vehicles? 50. N is 50. We want to show the distribution for xbar, correct? So mean is exact same as exactly, and then a standard deviation divide by 50 exactly. So let's rewrite this. X bar has a normal distribution of 50, 1, 2, 3, and did you find it?
4.97.
4 point
494.94.
49. 4 point 9. Correct? Is that correct? So now this was part C. Part B. So we know the distribution is normal with this mean and a standard deviation. Yes.
Will it be wrong if we leave it like that?
No, at all. But I am writing this down just to make sure. Yeah. This is easier. So we call this a standard error.
Actually.
And it's easier to replace that in Z.
Yeah.
Right? Because most of my students, I saw that when they replace something like this in Z value, x minus mu, in Z, to find a Z, first they will divide x minus mu by 3,500 and then divide by this, which gives you a wrong answer. Did you know that?
Yeah.
So if you divide this by this one and then this one, it will give you a wrong answer because there should be a parenthesis here. You are dividing this numerator by whole thing here, not separately.
Yeah.
Otherwise you will get the wrong answer. So that's why I am, finding the standard error so we can replace it. Okay, so part C. What is the probability that sample mean lifetime for these 50 tires? Well, it should be 50 tires.
Yeah, that's what I was
Because
thinking
if
too.
it
I was
was-
like, if 50 vehicles, I was thinking
We
we
would-
had to multiply by 4.
Exactly. I didn't pay attention to that. Yeah. But maybe the purpose of example was like that because I didn't write this. But let's say tires. But now you know what is the difference. If it was vehicle, it means we have 4 tires. We should multiply that by 4. But let's assume that we are talking about tires, right? Okay, so we start with x bar equal what? 52,000, right? We find the z value for this, which is x bar minus mu divided by sigma over square root of n, equal to 52,000 minus 5,000 divided by, now we know 9,7. Okay, so give me the number, final number for z value.
4.04.
4.04 positive, right?
Yes.
So now let's see how I can draw a graph. 0 is here. Let's say 4.04 is here, right? Then what it says, more than or less than? Exceed this much means more than. Means this small area, which would be a smaller. I'm just, making it more obvious so you understand what's going on. So to find the area to the right side, because we cannot find it from table, first we should find the area to the
Left side.
left side. And this one from table is almost 99.9999.
Yeah.
Almost 1, right? Almost 1. Do you understand this, all of you?
Yes.
Okay. So to find this, we should say this area now is 1 minus almost 1, which is almost
0.
almost 0. So how we explain this? There's almost 0% chance.
That a car exceed 52,000.
There is almost 0% chance. The average of 50, let's say tire, because we talked about this now. Tire, average of lifetime. For these 50 tires, exceed what was that? 52,000 miles. Correct? Do you have any question? Okay. Are you sure?
Yeah.
Everything is good?
Yeah.
Okay, so let's calculate pizza dimension. Okay, so what it says, suppose the diameter of a small pizza made at a restaurant are distributed normally with a mean of 11.5 inches and a standard deviation of 0.4 inches. So, mean standard deviation. What is that? 11.5, 0.4. It says, what is the probability that a single randomly selected pizza has a diameter less than 11 inches? So we start with x equal 11. Z is x minus mu divided by sigma. 11 minus 11.5 divided by 0.4 equal to negative 1.25, and then negative 1.25 here, more than or less than? Less than. We want this one. Okay? So from table A, we find this to be this one. So 10.56%. There is 10.56% chance that what? A pizza has a diameter less than 11 inches. So there is 10% chance that they give you a smaller pizza.
Oh.
So this time when you go to restaurant, claim your money back. There's 10% chance. You can, you can take your measure with you and try 10% chance means if you order 100 pizza, 10 out of this 100 would be smaller than 11 inches. So how you cannot love a statistic? Now even in restaurant you remember me.
Well, what percent that is
I mean
bigger?
when you order pizza actually, you remember me. Huh?
What percent of that is bigger?
Shall we calculate that?
No.
Yeah, the other one says less than 2.
What is that? So you don't have to calculate. Tell me, what percent is more than 11.5 inches? Almost 90%? So forget about it. You cannot, argue that in restaurant because 90% of the time they are giving you,
89.04%.
Yeah.
Hopefully I'm part of that.
Okay, so forget about that. You don't need to fight because 90% of the time they are giving you a bigger pizza. Okay. So part B says, what is the probability that average of? So now if you order 5 pizza, on average, what happens? Okay? So let me calculate this. X bar is equal to 11 inches and N is 5. So now the question doesn't ask you to find the distribution for X bar, correct? So we are directly going to apply all our knowledge here, and we should calculate sigma over square root of n, right? So I always do this. Even though I didn't ask you or I didn't see any question about what is the distribution, I will write it down because here also I wrote it down, the distribution of population, right? So here also we can write it down. We have a normal with the same mean as population, but the standard deviation changes to 0.4 divided by square root of 5. So X bar has a normal of 11.5. What is the standard error? What is that? 17?
0.18.
Is this good? No?
Yeah.
Yeah, it is.
So I kept 3 digits just to be more precise. So now let's continue. We have X bar equal this. We should find Z value, right? And then what is this one? 0.729 equal to negative what? 0.5 divide by equal to.
I got 2. Well, I didn't use 1.7. I used more decimals.
Okay, so what we do? We say approximately.
I put
2.8.
2.8. That's it.
We need 3 digit, right? Okay, so let's see. Negative 2.80. More than or less than? We should find this one. What is this? 26. Is that 0026?
Yeah.
Yeah.
0026.
0.0026.
Which is 0.26%. Is that correct? So, okay. So we should write down there is 0.26% chance that if you order 5 pizza, okay, if you order 5 pizza, average of these 5, on average, this 5 pizza will have diameter, what? Okay. So if you order 5 pizza on average, there is 97% chance that the diameters are more than 11 inches. Okay? Do you have any questions?
No.
Sure.
Yes.
So let's see what time is it. 5 minutes. Okay, I extended chapter 12, and for chapter 15 also you have more time. Okay. Do you want me to extend chapter, that pop quiz I made?
Yeah.
Do you? How many of you? How many of you want me to extend that pop quiz, like that practice quiz for chapter 3? Or you just don't want to try it again? Frustrated.
Wait, if we already did it and you extended it,
Actually, you know what? If you already finished it and you're not satisfied of your grade, and let's say you exceed all your trial, you finish all your trial,
okay.
so I have to extend the trial. I mean, open the trial.
yeah, let's do
Right?
some of those.
Do you want that? So your problem just was trial, so you could just ask me.
Yeah.
Oh yeah.
But I'm not going to extend that until tonight because I want to see how the other classes. Okay?
Wait, so the homework that was due on Friday was extended now? Okay.
It was Wednesday actually. I think. 12 was Wednesday. It was Friday.
Yeah, it's Friday. So it's extended till today? Yeah, we did.
Yeah. One more, thank you.
And then they use
I thought I did. We don't have class. Wednesday. So you cannot be like Wednesday in any of classes at all.
You tell us that.
Thanks.
I was like, whatever, because you guys weren't answering.
Yeah, we were on that farm.
So, wait, I just forget on that.
This is normal.